Hi everyone, welcome to lesson 5 and 6. This is the fifth and sixth lesson of our polynomials unit. In this lesson, we're going to talk about sum, difference, product, and quotient of a function. Before we get there though, we're going to start with our opener question today. So we have this function is divided by x minus 1 with the remainder of 6. When this polynomial is divided by x plus 2, the remainder is 12 this time. What's the value of k and m? So what we want to do is use our remainder theorem. That's where we're going to start up, and we're going to set up our remainder theorem. So setting it up, it looks something like this. So I'm going to sub in x minus 1, so that of course means polynomial at 1 is equal to 6. So basically in this polynomial, I'm going to sub in 1 for every single x value. So I got k times 1 cubed plus m times 1 squared plus 1 minus 2, and that's going to equal to 6. That one there should have been in brackets. Cleaning this up, this is now just k plus m minus 1 equals 6. And of course, getting k and m by itself, it's just k plus m equals 7 now, moving that one over. Doing the exact same thing with the other bit of information we were given. So we were given the factor x plus 2. So this is really, we're going to test polynomial at negative 2 equal to 12. Again, so k negative 2 cubed plus m negative 2 squared plus negative 2 minus 2, and all of that's going to equal to 12. Cleaning this up, we get negative 8k plus 4m minus 4 equals 12. And of course, we want k and m by themselves, so we're going to get rid of that 4 by moving it to the other side. There we go. From here, we're going to set up our systems of equations. So I'm going to double stack my formulas. So I have k plus m equals 7. That was the first one. And our second formula was minus 8k plus 4m equals 16. Here I'm going to eliminate one of these variables. The variable I'm going to eliminate is m. So I'm going to multiply everything here by negative 4, and let's see what we get. We get negative 4k minus 4m equals negative 28. Below that, nothing's changed, so we're going to keep that the same. Minus 8k plus 4m equals positive 16. Here I have my systems of equations set up. I'm just going to put an addition sign in front, equal sign underneath, and start my process. So I got negative 4 plus negative 8, that's negative 12k. My m's would cancel because I have negative 4 plus positive 4, they would cancel. And negative 28 plus 16 is going to get me to negative 12. Here, isolating for k is going to equal 1. If I know k equals 1, I'm going to find m. So that's the same thing as saying 1 plus m equals 7, and of course m has to be 6. And there we go. That's our opener. Going into today's lesson, so we're going to be talking about sum, difference, product, and quotients of a function and what happens. So there's two different ways you can write all of these functions. So if you're trying to add two different functions, f of x and g of x, you can write it out as f of x plus g of x, or you can combine it as bracket f plus g of x. So you can combine the functions right there. Same thing with difference or subtraction. It's the same thing. You can have f minus g in brackets, or you can separate them individually as f of x minus g of x. Your product rule is the same thing. Multiply either within the brackets or separate it out. Quotient is the same thing as well. Just make sure that your division is going to be f and g together, or f of x divided by g of x. In this case, g of x cannot equal 0 as well. So going to our example here, we have function f of x and g of x given to us. Find the resulting function h of x and the resulting ooh, and the resulting domain. So we want to find a bit of both. So let's start with addition. So for this addition, we're just going to take our two equations and we're just going to add them up. So I set up h of x. That's going to be my new polynomial. Is equals to f plus g. So f, um, and I'm going to throw it in brackets, by the way, just to double check a few things. 3x plus 2, that's f. I'm going to add x squared minus 4. So really, when you're adding polynomials, you could just drop all the brackets and it doesn't really change anything in the second. So dropping all my brackets, I have x squared, 3x, and negative, or sorry, 2 and negative 4 make negative 2. There we go. So if this is my function, I'm going to go straight to my graphing calculator to figure out the domain and range for it. Clearly, it's going to be a parabola. So let's see what we get in terms of our range. So graph, zoom 6 there to get back to normal window setting. There we go. That's my parabola. Domain, because it's a parabola, domain is always going to be equal to from negative infinity to positive infinity. That's wrong bracket. That's my domain. And of course I need rounded brackets. My range though, what's the lowest our graph goes to the highest it goes? Well, let's take a look at our graph. The highest it's going to go, positive infinity. The lowest it's going to go is right down here. That's going to be my minimum value. I'm going to go second trace option 3 to find that minimum value. So I'm going to go left of where I think that minimum is, right of where I think it is, and guess where it is. And I guess it's right there. So my minimum value at negative 1.5, I'm looking for this y value here, negative 4.25. So here, our range is going to be the lowest it's going to go is negative 4.25 all the way up to positive infinity. There we go. That's the first one. Our second one, uh, h of x is equal to, and again, I'm just going to throw these in brackets. So I have 3x plus 2 subtracted by x squared minus 4. And now in this case here, with the subtraction sign, it does play a role in our question. All it does is flip around all the signs of the second bracket. Now I can drop the second bracket and combine all my like terms. So here I have negative x squared plus 3x, and of course that's going to be plus 6. So again, to figure out my domain range, going straight to my graphing calculator to see what I get. Again, because it's a x squared, it's probably going to be a parabola opening down. It's 3x plus 6. There we go. There we go. So we do have a parabola opening down. We do want to find the max in this case here. Second trace option 4 was the max. I'm going to go left of where I think the max is, hit enter. Go right of where I think it is, hit enter. And guess where it is, hit enter again. So my max here, 8.25, 8.25. So my domain is going to be, again, from negative infinity to positive infinity. There's no stop to it. The range, the lowest we're going to go is negative infinity, and the highest we're going to go is that 8.25. There we go. For C, we're just going to multiply these equations. And again, be sure to use brackets when you're multiplying. So h of x is equal to, so what do we have? We have our 3x plus 2 multiplied by x squared minus 4. If you can't remember, this is a binomial times a binomial, so you'll have to use distribution. So if I distribute this out, I'm going to get 3x cubed minus 12x plus 2x squared minus 8. And then sorting it out properly, we have 3x cubed plus 2x squared minus 12x minus 8. And there we go. We have our equation. And again, degree here is degree 3, so most likely I'm looking for a cubic graph somehow. So let's see what we get. and minus 12x, there we go, and minus 8. And there we go. So we have our cubic function. So what's our domain here? Domain of a cubic function is from negative infinity to positive infinity, and our range is from negative infinity to positive infinity as well. Last but not least, we're going to do a division statement. So h of x is going to be equal to 3x plus 2. And all of this is divided by x squared minus 4. So first things first, from our polynomials unit, again, just an FYI, we want to factor everything. Factor whatever you can factor here. So my numerator is just going to stay the same, 3x plus 2. My denominator in this case is going to become x plus 2 and x minus 2. And why did I want to factor? Once I factor, I'll see as vertical asymptotes. So we're going to have x, basically a NPV, or in our denominator, let's state our NPV real quickly. X cannot equal positive or negative 2, and again, those are going to be vertical asymptotes as well. So let's see what we get in terms of a graph. So I have 3x plus 2, and there I can write down the factored form or the full equation. I'm just opting to write down the full again. But I do know that because I factored it at negative 2 and at positive 2, I should have had two asymptotes, which I do. And I clearly see another one right here, but it should be okay. Let's take a look. So our domain here, domain is going to be, and because we have multiple pieces, I'm going to switch back to set notation x such that x cannot equal negative 2 or positive 2, but x is an element of real. For my range, y such that, what can't y be? It looks like we're skipping the number 0 there, and most likely we could have had an NPV here at 0, but for now I know that we're trying to skip it, so I'm going to say y cannot equal 0 as well. Oh wait, no, we have small over big. Actually, we don't have any asymptotes, so I can say y is an element of a real. And there we go. That's the first example. In the next example, we're going to do the exact same thing, but this time we're just going to be working with radicals. So if we're adding radicals, again, I'm going to go h of x. I don't really need brackets, so I'm just going to drop brackets whenever I'm adding right away. So I'm going to go 2 radical x minus 3 plus x plus 1. There we go. And in this case here, you can't combine any of the radicals because you don't have anything in common. So we wrote our h of x and state the new domain of each function. So the new domain of each function is dependent on our radical and our restriction. In this case here, we have a restriction of x has to be, so x minus 3 technically had to be greater than or equal to 0. So x had to be greater than or equal to positive 3. Over here, we have x plus 1 under the radical had to be greater than or equal to 0. So here we'd have x has to be greater than or equal to negative 1. Because we have two restrictions here, which one do we pick? We always pick the larger restriction. So my domain here is going to be x such that x has to be greater than or equal to 3. X is an element of a real. For this next one here, we're going to do the same thing. So h of x is equal to 2 root x minus 3. And all of that's going to be subtracted by x plus 1. There we go. And again, the same thing here, where our restriction is going to be our domain. So our domain here, x such that it's going to be greater than or equal to 3, and x is an element of real. In example C, we want to multiply these together, so let's see what we get. So we have h of x is equal to, in bracket, 2 root x minus 3 times x plus 1 under a radical. And here, if I multiply these together, it doesn't really change my domain. Again, my restriction for my domain is still going to be my domain. So my domain is still the same, x such that x has to be greater than or equal to 3, and x is an element of real. And finally, over here for our division statement, h of x is equal to 2 root x minus 3. All of that's going to be divided by root x plus 1. And in this case here, if you want to rationalize the denominator, you can do that. But here, that was our setup, and all you have to do is figure out our domain. Again, domains can be still the same thing. You don't want our denominator to equal 0, and it still has a restriction of, same restriction by the way, of x such that x has to be greater than or equal to 3. And there we have it.